Hello and welcome to Steve's Long Stay Workshop, where stuff comes to be looked at for various reasons. This is a McMicheal. The last one Michael had was a bit of a swine, so I've got the details this time in advance. This one is from about 1946 or thereabouts. Strangely for that era, this actually is one which is not transformer driven. It's got a balance resistor. Now that is a problem per se, as long as the switching at least live and not, in this case, neutral. Look at the circuit and you'll see why I'm not actually putting this power onto this one straight away. Right, first of all, the live splits in two, goes to the anode of the rectifier, which is a CY31 in this, by the way. That's half-wave rectifier, by the way, and through here to the valve heaters, yeah, to the chassis. Now I like a chassis to be at neutral and not held above neutral. And on this one, it's held above neutral by the dial bulbs and a resistor. Nice. And the switch, by the way, is after the dial bulbs and the resistor. So with this radio, when it's plugged in with the main socket wired correctly, this radio is potentially a lethal, and it is like that by design. Why, here you ask, is it like that by design? Well, it's quite simple. In 1946, things were not quite as close and managed as they are now with the electricity, and also then people knew not to stick their hands in the back of a radio when it's working. People were clever then, they're not now. But anyway, even then, you can in fact put your fingers in the back of this and get potentially a nasty electric shock. Yeah, nice radio, but probably very nice actually, but like I said, it certainly is a very nice radio. You know, this is our radio you give your mother-in-law for Christmas, isn't it, back in the day? Right, well, let's go. The set is held on by one screw out of a lot more, so somebody has obviously been in here before, so new screws will have to be obtained from my junk box, and then we'll but that is, shall we say, quite a long way in the future, because at the moment it's going to be a case of have a look and see what is going on, and also can the set be removed easily from the case, because if it can, I'll get this case out of the way, which I'll probably will anyway, you know, but if it's easy, then it's easy. If it's hard, you know. That's the way these things are. Anyway, that comes out, and we'll have a look at the radio itself. Oh, right, fair enough, yeah. Well, in this case, first thing you do is have a look. And the first thing you do is always have a look. That's been added by somebody. As has that. The capacitor under the chassis, you can't see it on video here, but there's parts under the chassis which have been added or changed. I don't know where the smoothing block is, it must be under the chassis there, and so it might be simply a case of remove and hope before we do anything else. With that out of circuit as well, like I said, I've got the details here. So cable, no problem, we've got cable, no problem. That lot I will replace with a dropper, capacitive dropper, because obviously something's gone wrong here and I want to put it right in a safe way. By the way, the reason why I use droppers in these situations is because this and this will put out a lot of heat, more than the valve actually, and if it's replaced with a dropper, then the radiator runs cooler, and so that can be done relatively easily. Looking at the circuit diagram here, that is added, and this is probably been added as well. So straight away here, we've got to rebuild the power supply and rebuild it safely and correctly. That is our first port of call before we do anything else. I mean, I cannot believe also that chassis to neutral is via 2 more light bulbs. I mean, I'm sorry. That is a very dangerous bit of work. That. Okay, maybe at the time it would have been all right, but now it most certainly is not. This is my point. One on the chassis there. Switch on the new meter, and let's go to the chassis here. That might be through the bulbs, that I don't know. So the bulbs might be okay, in which case I will probably reroute the valve heaters to include the dial as well. The manual says that was for more protection. Well, maybe that's the case, but at the same time, you know, I'm sorry, you know, I can put a fuse in the plug of a low rating for that, so that's really not something which I would do these days. Anyway, also we'll do very quickly is get the sheet here like that, and next thing we're going to do is go between deck, which is here, and this resistor, and here, which is this resistor here, and there should be, please, there should be a reading. If there is, it's purely because of the valves. So let's see if there is. No. No. I bet there. One K, right. Let's have a look at R27. There's the it's here and here, so that should be at 812 ohms. And so from there to deck, it should be a little bit more than that, I think, shouldn't it? Right, okay, not to worry. Well, like I said, that goes to deck, as you can see. So that goes to there. Okay. It goes to there. Now, if I was to pull a valve out, anyone, doesn't matter. That one will do. Yeah. CY31, by the way. Now you see there's nothing anywhere. Yeah. That proves that the heaters are all right. So the valves are, I hope, all right. I hope. So that's something else. but I will not put anything through this set until our loss of power supply has been made safe. I mean made well and truly safe. So, next thing we do is first of all, set goes on its front, like so. And we start taking out screws. This might be a problem because they might have been in a long time, but we never know. So that one comes out. This one comes out. Okay, that obviously, and now of course these come out as well. One way or another. One way or another, and of course the front as well. And then the chassis should just slide out. I hope. The wires look to be in reasonable condition, not brilliant but reasonable. Some might change and some may not. That's I'll look on the chassis the rest of it, you know. But at the moment, this is looking like it's going to be a little bit of a problem. The bottom two nuts and bolts have been removed with this, and now if we take out the knobs, hopefully it will lift out the back. At which point the speaker as well, which should come out as well. Again, I hope. Now, when bump screws have not been removed for many years, they can be a bit of a problem. Don't panic. Just keep at it. Be careful not to make the threads any wider on top, and they will come, as you've seen there. If one doesn't want to come, leave it and then go back to it when the rest are off. Okay, don't get caught up with one. The moment the job is simple, getting everything out of this. With everything out of it, then we can start about getting the thing apart, and of course from that working, which is what the exercise always is with the radio. Always get the thing working. None of this I'm using it for spares or anything like that. If it worked before, it will work again. If it's been wet or something like that, chassis can be painted. Don't ask me how I know, but they can be. And in that case, you know, you can really can bring a radio back from the dead. I think whoever worked on this before knew what he was doing, or she was doing. After all, got to be take opportunities, haven't we, these days? So I don't expect anything really bad in this, but at the same time, always be on the guard, particularly with what I've seen under that chassis. Well, the middle one there was stuck fast actually, but I don't think it matters because I think we can. The lock comes out, so that is not going to be a problem as yet anyway. I'm going to take the speaker out as well, by the way, and then this chassis, this cabinet can go on the floor behind me, out of the way. then we can have a look under the chassis and find out exactly what, if anything, is going on here. Under the chassis, by the way, I don't think, I know you won't see it on camera, but there are capacitors floating about in space held together by wires. So somebody has been playing around with this, so I think it's time for some putting things right, as it were. I'm also, by the way, going to find out about putting a new flex on and wiring it correctly, because as I said just now, chassis should always be tied exactly to neutral and earth. If you should play about with live mains, which I do not want anyone to do, by the way, because it's not a good idea. You know, there's only one of the three wires that will give you a shock, and that is live. Neutral is earthed at the station, you see, the power station, so it doesn't matter quite the same, but you know, the one that is dangerous, as it were, is live. Right, anyway, I'll get this out of the way and go back to you, and we'll have a look at the chassis. And there the unit is apart here on the bench, and that moving cabinet is out of the way. Anyway, further evidence that somebody's been playing about with it is that these were not connected to anything and they just came out. That is, judging by what's been written on it, if it's right, that's probably the across the mains capacitor. But this one, I don't know. So let's go on the chassis and have a look and see what is happening here. It looks fairly clean, but obviously some of these capacitors will need to be changed. Obviously, that's new. I think that they're probably okay. That yeah, needs to be sorted out properly. And here there's this one here, which yeah. So most of it appears to be in reasonable condition. But as it stands, I am not going to do anything with this until I know exactly what needs to be done. Also, I've noticed that the on-off switch here, it appears to be stuck in the on position. That's something else I have to look at as well. And also, I hope that that is earth. But it's not. It's very close to here. If you look there, you see. So that's something which I think it is earth actually. But if it's not, well, yeah. But it appears that this is not what it should be. Nicely done, I'll give it that, but I think it's time to start with the snippers, don't you? So that comes off there. It comes off there. Okay, that's the yeah, that's the old mains core gone. What else? There's supposed to be two smoothers in this. There appears to be only one. So I have a look and find out where the other one is supposed to be or is meant to be, because it doesn't appear to be anywhere it should be. Yeah. So get the circuit and have a look. And also with these, by the way, there's also wiring of where things should be. Where they are and this where they should be are two different things, I'm afraid. But these things do happen, don't they? Right, anyway, there's the chassis underneath, and so first one we're looking at is D28, which is here, which appears to be replaced actually. Put that there. But I'll check it and make sure it's okay. Also, that has to be a Class X capacitor across there. I think it is, but I'm not 100% sure, so I will check that, obviously. There's also this thing here. Don't know what that is, but I'm sure we'll find it soon enough. One's looking for a C26 and C36 and C37. C36 and C. They're 20 or 36 now. .36 and 37 and R25. So let's find R25. It's here. Okay. So that should be over here. Well, there should be a can, which there isn't. So somebody here has modified this power supply, which is no problem. I can modify it myself, you know, which I'm going to do anyway, so it's not such a problem. But I'll take the oh, it's both. Okay, so I'll take that anyway, because I want to replace that. So no, see, yeah, it's this thing here. Yeah, I read the diagram wrong. We do that, by the way. Don't be afraid, by the way, of checking and checking again when you read diagrams. Yeah, don't ever be afraid of doing that. Okay, just don't. Okay, because reading a diagram wrong is something which, again, everybody does from time to time, even me. And although Andy does call me the Oracle for reasons, yeah, and everybody makes a mistake, and that is everybody, even me. So always be ready for it, and I think this is going to come out. And so yeah, that's I've got 400 volt one that's what I'm going to put in here, which will be fine. Okay. That's one. That's two. Right, so that can that might be okay, but I'm going to replace them anyway. Okay, and they go here. And this one, this wire here, should be earth. Again, I'll check and make sure. It is. Yeah. So that's okay. So we know that we want cats for that. Okay. Now the other thing here is this is this little mess here, which I'm going to do something about right now, because I have to really. Again, over here is the chassis and the volume control. Now I'm going to disconnect here as well. I'm doing that because on this machine, this radio, the it does appear to be connected to Earth. Now I don't like the idea of having this going to Earth, so it's going to come out. Yeah, that's the light. That's the light. Okay, that's the light, is it? Yeah. Okay, that's the light. That's the light. But the lights again are going to be changed. I'm not putting the lights in series with the Earth, this in any way, shape or form. So these are going to come out as well. Yes, it's not the lights, is it? Well, that one is. Yeah, okay. So that comes out, okay. And this one goes over here. And this one comes out as well. By the way, if you take out a wire that you shouldn't do, don't worry about it. Got the manual, you can usually find it where it goes, so that's not really a problem either. Because that is going to go now to well, not to there anyway. Right, so that comes out. And back to the bin because it's a bit knackered. Yeah. Right. So now we've got a situation where the main side is ready to be rewired and rewired correctly. Okay? I'm just not seeing replacement knobs really. I might be able to yeah. Okay, well in that case if that's a replacement knob, then I might be able to put both neutral and earth through it and back over here. That'll be a bonus if it is, because that is very, very important. The next thing, there should somewhere be an 8-put transformer, and the 8-put transformers on these tend to go from the HT line to the anode of the 8-put valve. Yeah. Now, one thing to look at here, something to be very aware of here, is that there are two power sources, as it were, to the 8-put valve. One is the anode, and one is the second grid. It's called control grid, yeah? If the transformer here goes open circuit, Yeah. The 8-put valve will not last very long. That is because, if you look at the circuit, there's the circuit. The reason why it does that is because when the 8-put transformer is not in the circuit, the valve will still be getting power from that grid. Yeah? Look closely, see? Now when that happens, the pentode tries to act as a triode using that grid as an anode. And generally speaking, they don't last very long. So best not to let them try and do that for very long. So always check the 8-put transformer as well. Now 8-put transformers do go, don't get me wrong, they do go, and when they go, they do go, shall we say, somewhat spectacularly. And so for that reason, you know, always be careful of what you're doing with them. Because if you don't, you might have a problem on your hands. Not an insurmountable one, don't get me wrong that way, but you might have something unpleasant on your hands. So again, yeah. So some transformers, by the way, some radios, the 8-put transformer also acts as part of the speeding circuit. So be ready for that as well. Okay, not on this one. It goes on R25, which by the way is on this one 2K, which I'll also check while I'm here. But the first thing I'm going to do is find out about whether this is okay. If it's not, don't worry, because we can always get another one. No problem there. That doesn't look terribly good, that actually, does it? That's okay. Okay, right, well that's okay. And we got it set with a false 8-put transformer. Oh, not okay. Doesn't look like we have. Two and 1 and 3 and 4. Okay. So there to there should have a reading of T1, 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 300 ohms or thereabouts. Okay, fine. Let's try and find it and see, shall we? Something isn't right here. Something is definitely wrong here. Right. well, valve for the anode, and it goes through there to one half of R25, which is here. So that goes onto there, that goes onto there, that's okay, and that should go to this valve here. So something should go down here. To one pin, I don't know which one. But one pin down here. So again, I don't know quite which one it will be, but right, anyway, from there we should go to one pin up here, possibly through that resistor. Oh, there we are. Okay, fine. So that's through that resistor. Okay, going on the end of it, therefore, there should be 2K. Please. Yes, there is. Okay, fine. And there's nothing to there. And that goes to there. And that should have on it a resistance of some kind. And it doesn't appear to. That's worrying. Not to worry, but we can get another one, no problem there. Get another 8-volt transformers, no problem there. But certainly an issue in one respect, isn't it? Yeah. Good of it. Never mind. These things happen. These things are sent to trials, so they do. Never let something like that mean the end of a radio. Okay. So therefore, we need possibly an 8-volt transformer. I'll check and be sure of that. But if it is, well, it is. That's the way it is. Capacitive dropper circuit. I'll find out why that is not switching on and off the way it should do. Then of course, when you do a capacitive dropper circuit, by the way, you can't just go Ohm's law straight away. You've got to do it using AC theory. There is a program which does it on power sending side, but if you've not got that to hand, or you're like me and you like playing it with math, yeah, no, then I'll show you how to do it. But I think the next thing we do is see about taking off this lot here, because it's going to be redundant. By the way, this was something which back in the day was an acceptable repair, but again, as I've said before, times have changed, and so for that reason it might be acceptable then, but it isn't now. Okay, so, and also I think this has got asbestos on it as well, so if it comes, okay, and out that comes, and there we are, and we'll clean that up as well, and take out this as well. Also this here, again, it's so that comes off there, and this should come off here as well at some point. If that's okay, I might keep that, but the other one obviously needs to be handled rather more carefully than I did just now, so I'll take it out of the bin and get it and dispose of it properly at some point, like now. The thing that worries me about this radio actually is that transformer is most definitely open circuit, and if it's been run that for a length of time, it could damage the input valve, which is this one here. I don't know about that yet. Might need one of those, might not. These actually take a lot more, not that much more abuse than say the smaller B9A and B7G valve. But anyway, capacitors I'm going to be replaced. But look at something interesting. Look at this. Yeah, this is shows you what we're at with electronics these days. Yeah. 0.5 microfarads, 250 volts. Yeah. 0.7 microfarads to 0.47 microfarads. Yeah. 600 volts. Look at that. From side by side. It's amazing, isn't it? But anyway, now I'm going to go through and get the details. I'll show you how to work out, again, show you how to work out a dropper capacitor for the heaters. So the new leak power supply is going to be like this. First of all, the switch is going to be transferred to the live rail here. Yeah? And those switches, those lamps there, are not going to stay there. So the chassis will be linked straight to neutral. By the way, I don't recommend it, but only one out of the 3 connections they made will give you a belt that's alive. But don't do it, okay? Just don't do it, please. So, what will we do? Well, first of all, I got second point with. There we are. And like I said, that switch there goes to neutral, yeah, which is down here, neutral, live and neutral, okay, and neutral, both bulbs come out until the chassis goes straight to neutral, yeah. Now, the wattless dropper, capacitor dropper, is going to replace this here, which is, I'm going to take out the rest of this tonight and put it in its place. Capacitors have been bought for it, and it's very much smaller, and also, as I was saying earlier on a website, no heat at all, none at all. So the HT will go in the same way as before. Okay, that's as it is, yeah. And so valves 1, 2, 3, 4 and 5 and the scale lamps will go here, yeah, and that will be replaced by capacitor. Now the one thing here is the capacitor itself, yeah. First thing we do is work out the valves, yeah. They all carry 0.2 of an amp. That's important. Everything has to carry 0.2 of an amp. Okay? And so I've got a CY31, which is 20 volts, a CL33 carrying 35 volts, an EF39 carrying 6.3 volts, an EVC33 carrying 6.3 volts, and a CCH35 carrying 7 volts. And the bulbs, of course, 6.5 volts each, which comes to near damn it 75 volts. Yeah? So if you take that away from 240 volts, which it is round here. I know people say 230, but here in many areas it's still near to 240, which is what I use, yeah. But you can't just go 240 volts minus 75 equals the reactance or resistance, if you like, and to AC to the capacitor. You can't do it. You've got to be civil about it. Now, civil, C-I-V-I-L, tells us that in a capacitor, current leads voltage, and voltage leads current in a coil. But either way around, it's always 90 volts, okay? Anything you plug into mains, or any two wires that got current on them, they will be either conductive or capacitive as well. Okay, that, by the way, is why my mains is stuck at 50 volts and 50 hertz, of course. 50 hertz, yeah, 50 in the US. Now we'll come to that a bit later on. So what we do, because it's a 90-degree signal, when we're at school, did you use Pythagoras? If you did, then C squared equals A squared plus B squared on a right angle triangle. So the main squared is 57600. Okay, that's C squared, yeah. The valve squared, I'll send you 5 squared, which is 5625 volts, and working that out that way gives us 223 volts. Sorry, 228 volts, yeah, which is what the capacitor has to drop, yeah. Now we know that the current is 0.2 amps, so we work out from that the reactance of the capacitor, which is like AC resistance, is 1140 ohms, yeah. Now XC equals 1 over 2 pi FC, yeah. Turning that round, 1 over 2 pi XC, yeah. Now we know 2 is 2. We know F is 50 hertz, 60 in some places, but here it is 50 hertz, yeah. And therefore, here is 100 pi FC, yeah. So work that out, and you get an answer in farads, yeah. Now a farad is a very large unit, so we've got to convert it to microfarads, which we do, and it comes to around 2.8 microfarads. So a 2.8 microfarad capacitor there on the circuit there, in place of that, will suffice, and it will light up the valves, but only on AC. DC mains has not been in this country for many years, so basically this sort of system isn't really used now. If you get set with it, plug them into mains, they'll work, yeah. But if the dropper or balance resistor fails, they won't, yeah. It had on this. So therefore, there are 3 ways of doing it. One is to work out the resistance for 240 volts and put a resistor in. Again, you can do that, but they generate heat, yeah. Another way is a diode dropping it down to 120 volts. Has to be big diode for this, obviously. Then a resistor. That's one way of doing it. But the capacitive dropper, it generates no heat whatsoever, which is why I like them. So a 2.8 microfarad capacitor, suitably rated by the way, goes there, and the valves will light up, which is what we're going to do now. And also I'm going to put the heaters and the bulbs together as well. Now, as it stands, when the bulbs go out, when one of them fails, as it stands, the whole set will go off. Still be live under here, under the rectifier valve, but it will go off because the heater will be off. So I put a nice big powerful resistor, about 100 ohms in as well. So if these fail, it isn't the end of the radio. Again, that's something which many of them do. So let's get on with it, shall we? Now you know what we're doing, let's go ahead and do it. Right, now these sort of jobs, even with all the working out in the world that's done on paper, you have to modify it when you're working as well. This is what I've done actually. Want another capacitor, a bit smaller than what I've put in. But at the moment, also I think two bulbs of a slightly higher wattage as well. Certainly lower current, because those are 0.3 volts, and the rest of it is 0.2. Those are cross resistor in the back here, which is 100 ohms, like before, like on the circuit before. So anyway, with that in mind, all the valves are all wired in series with that, and we then apply power. Now, when we apply power with these sort of systems, I'm afraid they do take a little bit longer to come up. Just the nature of the beast. So therefore, give it a minute, and then of course we go and have a look at the top here where the valves are. The meter, by the way, is on AC. Remember, we're working with AC here, not DC. So that meter there is on AC, okay? Not DC, AC. And so for that reason, that goes on that. And you see we've got 81 volts. A little bit high, but all the valves are lit. And like I said, I've got a bit capacitor to come in to make that a little bit nicer. So that appears to be okay, that respect. So that part of it is now okay. You might think I'm being a bit fanciful about the valves, which you can understand. I mean, it's entitled to your opinion, but I always want the chassis connected straight to deck. Straight to deck. Not often in a way, straight to deck. Vitally important. Wouldn't do it in the day, but now it is, so that is now vitally important. So with that working now, we now look at the other things we've got to do with this set. And the next thing actually is here. If I just reach for it, there you are. It is this. It is a speaker. And on the back of it is an output transformer, which is there, which is open circuit. That previously. So now I've got to take this off here, one way or the other, and this output transformer, I'm afraid it is going to be bin, because I'm not looking at it, because I've got a replacement for it. So replacement is going to go on. This is going to be redone properly and put into there, and then at that point we can start on the smoothing capture and the power supply. The HT power supply. The LT is as good as sorted. So now this and then the HT. And then after that, the dead spider there, then after that we might actually get some life out of this beast again after a long time. Part of the HT has been done. These capacitors here are the smoothing in Redwater capacitors for the rectifier, which is a CY31 on these. Now if you don't know the correct value for any rectifier of this kind, look it up and it will tell you the heater value, everything else, and also the top value that these capacitors can be for this valve. On this valve it's 32 microfarads, which I've got in both of them, which I've got there. So, but by the way, it's worth 2K as well, although I doubt that they were working quite the same way. On the top of the panel here at the way, and this here, which is going to be redone when more parts arrive, is the valve heaters dropper, of course. Now also with this, underneath I changed the grid capacitor for the 8-put valve. The 8-put valve on this, by the way, is of course a CL33. Like I said, this is one of these sets which has AC or DC supply, but now it's going to be AC only, because Is there anybody in Britain who still has a DC supply? Anyone? If there is, can you let me know? Because I'd be most interested, I really would. But now, here is a replacement replacement output transformer. And the replacement output transformer, because the one that was attached to the speaker has failed. And so it went the way of all things that have failed, which is the bin, of course. And so now I've got a replacement one here. This is one of these for anything. So, and it doesn't tell actually on this one which is which. But with output transformers, the primary is about 300 or 400 ohms, and the primary and the secondary, the speaker, is about 3 or 4 at the most. So, switch on the meter, like that, which is 200k, and that's not reading. That's not reading. That's not reading. Okay. So, therefore, this is probably going to be, that's 400 ohms there, 600 ohms there, and 800 there. So from there, which is 2 to 3, doesn't tell us anything, that okay. So 1 to 2 is something like 417 ohms. Okay. Then to there, 216 ohms, and to there, 146. So I'm going to connect it from between 2 and 4. The manual, by the way, suggests the input impedances of this transformer are, let me find out for it. Suggested that output is 300 ohms. No, that's 400 will do that, and the secondary is 0.3. So 2 to 4, and the other way around. A to D should give us 1.6. Bit lower, but there is with these considerable room to manoeuvre. So 2 to 4 and D to A. D to A go to speaker, and 2 to 4 go to the output valve and the HT respectively. No matter which way around the two cords go, but don't get them the wrong way around, okay? That's probably not well put, but basically D to A can go either way around to the speaker, and 2 to 4 can go either way around here. Because on all sets of this kind, can you read that? Can you read that? Can you read that? Okay, right. You see there, T1. You see the external loudspeaker. I'm going to leave that at circuit. Nobody's going to use that these days. So it goes between HT here and valve 4 here. Valve 4 anode to HT, which is where it's going to go. But those two can go all the way around, like I said before. So basically, secondary is secondary. Secondary is secondary. Primary is primary. Secondary can go other way around, primary can go other way around, but don't mix secondary and primary. Now, the fact that the manual says that this plug here, which is this one here, the fact the manual says it's made up a certain way doesn't mean it is. Okay, 99% of cases, 99.99% of cases, it will be. But always check, okay? Now we know from the circuit, which is here, that rectifier that goes to the output transformer to the anode of CL33, that's the output pentode. Okay, that's how it works. Okay, so we pick up the output of the CL33, which is here. Okay, we pick that up there like that, and see if it comes. It does. Okay, not therefore that one there. So that one obviously is the output valve. Okay, is the AC input to this transformer here. Okay, so therefore that one's the AC input. Okay, now at this point then we look again, and on the same side there's an A. That is the anode of the output pentode, which is a CL33. Again, tells us which pin is which on the circuit, pin 3. So that goes on to pin 3 like that, that goes on to there like that, and we'll look for pin 3 down here, which is always different, always a mirror image of when you do this with the valve. You always pin clockwise round from the tab. Okay, which is here. So put it clockwise, 1, 2, 3, like that. Put the tab in, and you see that it is probably going to be this one here. But again, check, because well, we don't know for sure, do we? It's that one. Okay. So we know that the two we want to are the two on the right of this plug here. Okay. So the two on the left, I'll take the wires out of them and put these two either way around onto the right hand side. And when that happens, the transformer will then be wired back into the circuit. Then of course it mounts on the speaker and connects, and the speaker goes to A and D like I said before. I have now done all the modification to this radio and put them all in. I've also put this output transformer, new output transformer in as well. By the way, never run a radio with a transformer and speaker in the circuit. That is because the output transformer and speaker, I'll just get the circuit, I know it's here somewhere, goes to the output valve. Template diagram that shows this properly. There you are. Now you see here, this is the circuit for the output here. You see now, I'll shift that, I'll switch it back on again. But if you see here, the CL33, yeah, if there's nothing on the anode of this valve, like I said previously, but there is voltage on pin 4, it will act as a triode, and it will tend therefore to kill that valve in pretty short order. So never ever run a valve without the speaker and the output transformer connected. You just don't, okay? Just don't do it. Always check it, okay? Also, this, by the way, is now on a capacitive dropper, as we know, and initially it didn't work, and that was because one of the resistors inside got an open circuit. Now, some of these older resistors, sometimes the ends of them break inside, and when they do, 125k ohm resistor becomes 18 megohms or thereabouts. They go open circuit. When that happens, of course, there's no EFT, so that's been replaced. So now I'm now going to plug it in now, and we'll see what happens. Also, with these sets modified in this way, they do take a little bit longer to come up, so be ready for that as well. Okay? But it just takes a little bit longer. That is because of the way the heater voltages are being step down on these. It step down through those those capacitors there, and basically, here we are. Basically, it does tend to go a little bit slow. Anyway, there we are. Well, it seems like it's alive. Let's see what happens. Certainly on the shockwave band here. Certainly sounds like it. Because we're on the shockwave band, any music that comes from might not be might not hit the YouTube copyright content, which is a pity actually, but you know, as far as I'm concerned with that, it's fair use, but anyway, they say not. Anyway, so this is on one of the vans, so let's try and get to another van. This is stuck solid, by the way, so I'll loosen it and we'll try a medium wave van, but it seems to be working at long last. The situation now is that with everything cleaned up underneath and components changed and checked, this valve, the CY33, that's this one here, has got a problem. As you can hear there, it will go up higher than that, but not very much. Now, this valve was run without the speaker and output transformer attached to it, which won't have helped matters in this latest, you know, with something I was worried about from the beginning. And also, I think this is low emission as well. How do I tell her, here you ask? Well, it's quite simple. If you look at a circuit like this, yeah, valve 4, yeah, has the anode, the second grid, and down to deck through R24. Yeah. Now then, heater's okay. I've checked it. It's fine. Yeah, no problem there. Okay. But the voltage there on the cathode is lower than it should be, and the voltage on the anode is higher than it should be. We know it's not a grid problem because I've changed that capacitor and bring the circuit up so you can see it. Can you see that? Hang on, I'll make it so you can. Hang on. I've now loosened it a bit. I'm going to medium wave band and
Scott Parker's side saw Jefferson Lerner sent off. Hearts have moved up to second.
There we are. That's
win over St Mirren. Meanwhile, England's women continued their 100% record in World Cup qualifying with a 1-0 win over Austria. In tennis, Great Britain beat.
That's Switzerland doing, but never mind.
This Cup group match.
Change pit and look cross into the pit.
It's an adventure like no other. Explore the landscape, get closer to nature, and learn more than you'd expect with our knowledgeable Hurtigruten Expeditions team. Search, follow your curiosity.
That's the radio basically working. By the way, I've got a meter probe on the grid of the CCH35. Again, if you look at the circuit here, like so, it's off by the way, so you know. Look there, you see, I've gone there, okay? The grid, yeah. So there, it's just that lot to the area, which I will check. That lot will probably be okay actually, once I check them anyway, but that's a very interesting, very quick way to see if they're all okay, or if you want someone to plug in area quickly, just bang it on there. On the grid, that's the top cap, but always check. Don't just put 1/2 a metre on a grid with radio it's switched on. If it's a grid, you'll get a bit of a bang, but most cases with these valves, it will be that grid there. Okay, so again, that's another tip from the top for you there. But it does seem to work after all this. The valves don't seem to be under any stress. But what happened, by the way, the reason why I take a bit longer to warm up, I was interrupted last time, is the way that those capacitors there actually drop the voltage. The resistive way, it just simply lowers the whole lot down. Yeah, so it goes from a big sine wave to a small sine wave, if you like. But in this way, it simply does it by first it takes on so much, then stops, then lets it go again on the halfway and so on. So it's not. It takes longer to the valves to heat up, but it works very well, and of course it is safer and cleaner heat-wise. So it's worth doing. Although the sets do take a little bit longer to come up, so be ready for that. Okay. So now it's a matter of tidying up my work where I can, and changing a few more capacitors, and this thing will be done. At that point, you know, now is the point where you do capacitor changing, because you've got all the faults. So now every capacitor you change, and there's one missing, I know. They do want to be changed, obviously, but I generally don't bother too much unless something is on an HT line or is carrying signal, which is basically both of them. So I'll look at the circuit now and see. Smoothing capture okay. The power supply is modified, that's okay. Yeah. Possibly that 50 volt one, 50 micro 12 volt one there. Yeah. Look at the circuit there, you see. That 50 micro volt 12 volt one, which is there. Possibly that. But I know for a fact there's one missing which needs to be replaced. So now it's a case of, in this situation, change your part, one part maybe two, switch on and try it. Change one part maybe two, switch on and try it. This is because, as I said previously, because if you make a mistake, it can be horrendous as you're trying to find it, and that is the way madness lies. So please don't do that, because you know it can end up doing a lot more harm than good in that respect. But anyway, it's actually now working. Oh, by the way, I've got some low voltage bulbs as well for here, so maybe we can make the dial light up as well. We'll see. The situation now is that with everything cleaned up underneath and components changed and checked, this valve, the CY33, that's this one here, has got a problem. So, I'll just give you that. It won't go up higher than that, but not very much. Now, this valve was run without the speaker and output transformer attached to it, which won't have helped matters in the slightest. You know, with something I was worried about from the beginning. And also, I think this is low emission as well. How do I tell her, you ask? Well, it's quite simple. If you look at a circuit like this, yeah, valve 4, yeah, has the anode, the second grid, and the deck through R24. Yeah. Now then, heater's okay. I've checked it. It's fine. Yeah, no problem there. Okay. But the voltage there on the cathode is lower than it should be, and the voltage on the anode is higher than it should be. We know it's not a grid problem because I've changed that capacitor I'll bring the circuit up so you can see it. Can you see that? Hang on, I'll make it so you can. Hang on. This circuit here, the 8-put pensode or heptol stage, yeah? Now, how do I know that this valve is low emission? Well, it's quite simple. The voltage on the anode is high, too high actually, and the voltage on the cathode, that's R24, is lower than it should be. Yeah, that means therefore that valve is not passing as much current as it should do because it's got a low cathode current. Now we know that the grid voltage is not coming from here because that capacitor has been changed there. Yeah, so all it can be, that valve, but that resistance valve is still at 150 volts exactly, so 150 ohms exactly, so that's okay. Therefore, all it can be is the valve. Nothing else can it be. Okay? Nothing else. Not a transformer. All it can be now is a valve. Now, replacement valves are about 20 quid. And so what I'm going to do, I'm going to leave it as it is. It's working. It's got good sensitivity, but it's not all that loud. And I tried it with a transformer because that was a new one, wasn't sure. It's slightly louder with this one, so I'm going to leave this one in. And without a valve tester, I can see that valve has had a hard life, shall we say, and it's feeling its age somewhat. So this valve is actually now the problem. The rest of it has been cleaned up, much as possible. So now we've got the problem with the lights. Now, on this set, as you know, initially the lights went between chassis and neutral via a switch. That has all been changed now. The lights are now here. Put that back. There we go. The lights are now here. Yeah. So I've ordered some bulbs to go in here. Now they're 0.2 amp bulbs and there's a 100 ohm resistor in the way. So if they fail, the radio will still work. Now look at the multimeter. Yeah. The two of them together, all they're getting is 3 volts. So lighting, but not enough. Yeah, lighting better with these 6.5 than they did with the 12, but not enough. So what I've done, I've been online, I've ordered 1.5 volts, 0.2 amp bulbs, which will go in there. When they'll come, the dial should, light up. But apart from that, this radio is near damn it done. The valve, like I said, it's best left really. You know. Like I said, a new one will turn up at some point, and when it does, in this set it'll go. But I'm not paying 25 quid for one. That's not too much. Way too much. Well, the both of these have arrived, and as of yet they've not been put in. But in the process, of course, when it's set like this is left apart in a workshop, other things tend to die on it, and they did with this. I did away with the speaker plug because it was basically knackered, so I got rid of that. It's here, so that's going to go that way. Now from that we now have this circuit here, which, as you know, is the output stage. Now all of a sudden R24 there went to open circuit, which meant this valve could not conduct at all, which did two things. One, the AC shot up because of course it wasn't being loaded down by this valve, and well, at that point I changed the resistor underneath and it started working again. Oh, great, for a second, and then when I was putting an aerial on it, which I've got now actually, it suddenly done to nothing with a little buzz. Oh dear, I thought. Well, at least that's what I'm telling you, I thought, you know. So looked at the circuit again, and I found the voltages on the smoothing caps, that's here and here, was down at very, very low level. Now, that low level there was because this cap had gone short circuit. Yeah, I did that by when you get a fault like that, I always try and find it with the radio unplugged from the mains. It's a bit safer. Not as much fun, but safer. So I disconnected the speaker, still there. Now with the speaker and the output transformer disconnected, all it can be is the valve or the capacitor. So the valve came out, still there. So skip that cap, and lo and behold, everything came back to normal. So I then put the speaker back on, put the valve back in, and as you will hear in a minute when it's warmed up, it will now have once again a workable radio again. Yes, I know that's my fancy aerial here, you know. So that's something which we do have to deal with. But with these sort of sets done like this, they do take a little bit warmer to warm up. As I said before, this is because of the way. Here we are.
Because he knows you can't keep accumulating these valves in these areas.
And they split 3 to the left, 3 to the right, 1 through the middle, they cut it to the right. This round.
He's in.
Cross.
You can see it's quite sensitive. I think that's where the car line actually coming in there very briefly. Radio car line is now gone up to a kilowatt, so we might get something here after dark, or before dark, I don't know. But now, of course, we'll go back to the same old problem of the lights, because of course on this set, the lights don't light up the dial. Now this might also, because if you look under here, there's not much light going down on the front here. So therefore, I shall put new bulbs in and we'll see what happens. It's not a good night tonight for DXing, I'm afraid. This is shortwave. There are stations out there, but they're quite weak right now. What I might do actually is link up to Gary's door, which I might try and bring some more in. But on medium wave in particular, this radio is very sensitive. That I think is Radio Caroline, which is not something we normally get here.
Did he get the pace? Did he have the pace to get away? The ball was straight to the middle.
That's 5 Live. Talk Sport. Absolute or Virgin, or they call it. My gold station there. And Curry FM. Sorry, Curry FM. So it's working. But the problem here with the dial, these bulbs are in and they're fairly bright, but they're not getting through to dial. I don't know quite why that is. If we take the top off here, which I'm going to do in a minute, you find that the bulbs are above little inlays to put the light down into here, but it's not going, it's just going it locally. Now, for that reason, first thing I might do is try and silver the inside of here to force the light downward. But I've got other bulbs coming which are brighter than these as well. So apart from the bulbs, everything's now working and fine. I'll leave it running for a while and hope that nothing else goes wrong with it. And now and only now is the time to do mass capacity changing, because we know that most of the faults in it are okay. The valve heaters are well within spec, and the only thing is these dials, these dial lights here. Now, initially, they were between the chassis and neutral. I didn't like that. Like I said, it was live, set, chassis, bulbs, switch and deck. Highly dangerous. So I've changed it all around and put a capacitor dropper in, because the one that was there was not working anymore, so I went the capacity route. And now, of course, it's simply a matter of sorting the bulbs out. So that's the only thing I've got to do with it now, is sort the bulbs out. The outer circuit came in with. Now, first of all, the dial lamps actually were between the chassis and either live or neutral, depending on which way the plug was wired. On AC, on DC, it would have worked one way but not the other. But nowadays, of course, in most countries, AC mains is persevered and won. So really, DC means something which you don't get now. So that's why I did what I did. Okay. First of all, this dropper was faulty, so I whipped it out and replaced it with a dropper. Now the dropper, I worked out the valves and put the dropper in. I've seen me do that earlier. And also the output transformer in it was knackered. I put a new one in. Well, not a new one that was nearly there, as it were. You get some lever with those. Three capacitors, obviously, such as that one there. Yeah. You have to change these caps, because otherwise things will fail and the valves will fail. And the valves on this are about 70 years old and still working. Surprising. One or two of them are a bit low emission, but it does come up okay, so I'll leave those, because I'm using this set a hell of a lot. Dial lamps, another plastic dropper is put in place to put the dial up directly across the mains. This was done so that whatever happens, as soon as it's plugged in, even if the rest of it is dead or a valve open circuit, the lights will still come on the front. So you always know when there's power, and that's why I've done that. Okay. Now the other half of it, this side here, this is the side with the mains on. You can see that. Yeah. Now this side of it, of course, there are three power sources to the CCH35. CCH because the heaters have to match up okay. These coils here are the oscillator stage, and these here are the output stage. The oscillator stage, one of them is not working due to green spot, but it's not something which is vital, so I'll had to let that one go for now. On this side too, I want to do some jiggery pokery to sort that as well. Basically, that cap there, through that cap, and go down here. I want to bridge that there, and it's started to work okay. In the old days, there wouldn't be that. There would just be an air socket, nothing else. None of that. So that's it. It's working there, but I certainly would not look at modifying this and selling it, because modifications to radios can come back on you if there's a problem. Believe me, they can. So anyway, it's now working again after a time. Also with these testers, by the way, don't rely on the on switch on the front here to run the radio and turn it off. Always on the back here. This is running through one of these. It's one of these, which is very handy. All you do, plug it in, and we shall get some. We'll get some lights in the back. And I know we do, because the lights, they can't see them on the camera. They are actually working and they're doing what they're supposed to do. So any minute now it should come up and start to talk to us again. And when it does, I'm going to leave it at that. So this one, McMicheal, is now working. The McMicheal set, very classy back in the day, but I must admit I've had two of them and they've both been difficult to deal with for one reason or another. The first one, the dual speaker one, the problem I had with that was the speakers themselves and the wave change stuff. This one,
say, I want to drive that Arctic, and all of a sudden you go out the gate and say...
This one, really, all due to an odd switch, because what was in it then would not be suitable now.
What's embarrassing?
Well, what's in it now is this. I mean, even now it's switched on.
Everything. I know what you said about coming on against Aston Villa. Yes, he did. He changed...
And not get a shock. That's very important.
Statement he made. It's been an embarrassment.
So anyway, McMicheal 471 working again. It came off eBay. It came off of Goldbomb, this, by the way, the Goldbomb, this auction at BVWS, and it does work rather well. So it's time, it's there, but I've done it. So until next time, it's Steve's Longstay Vintage Radio Workshop. I'll see you soon. Until then, take care, but goodbye. And remember, always keep fixing radios. It's the thing to do. Bye bye.